welcome back, class. We're getting ready to go back into section 4.3, and today's focus, this video segment, is going to focus on example 3 in section 4.3. So let's flip the page, and let me back up to this page. Slope of a line. This is our focus today. We're going to learn how to take a graph and calculate from it the slope of a line. And this is really important stuff. This particular page is a great setup for your knowledge about slope. And let's start at the top here. The rise, that would be this word right here, rise, is the difference in the y values of 2 points on a line. And then the run, that would be this word here, the run is the difference in the x values. You remember from examples 1 and 2, we did change in y over change in x. Well, now we're going to call that change in y something. We're going to call it rise, and the change in x is run. So we call it rise over run. This is such an important skill that you could ever develop with linear equations, is can you take a graph and use rise over run and calculate the slope of any line, okay? So of course they're reminding you, remember that y is the dependent variable and x is the independent variable, all really good things to remember. So this page is very, very important. It's a great setup for you as you're learning about slope. All right, flip the page. Now I created these. These are not actually in your book. Your book has an example which is on your next page. But this particular example, I wanted to create a couple of different scenarios for you so we could talk about it, and I wanted to show you in great detail and in great depth how to find slope of a line from a graph, okay? Your lines are in red. It probably didn't copy out that way, but on the video it shows up as red. So those are the lines. We're trying to find the slope of these lines. Now remember, from a graph, the easiest way to do it is to do rise over run. Rise means go up or down, okay? It's kind of like you're sitting in a chair. If you're sitting in a chair, your rise went down. That's a negative rise. And if you stand up from your chair, your rise increases or goes up. That's a positive rise. Run goes left and right, okay? And so that's your movement on the y is up or down, and then on the x is left or right, okay? Just in the same manner as your x and your y axes move, okay, and occur. All right, let's look at this very first one here. I didn't label it. Let's just call it A. This graph A is leaning to the right, and we want to calculate the slope. Now, I denoted and tried to show you some points that are on our line. Okay, those points actually cross particular grid intersections, so we know exactly the name of each of those points. I'm going to show you a couple different ways to do this. My favorite way is just to do rise over run. So let's pick a point. I'm going to start down here at this bottom point where my pencil tip is. Hopefully that showed up on the video. And the name of this point is 0, -1. I don't really need to know the name of that point. I'm just telling you so we're all at the same place. And so what I'm going to do is I'm going to go to this next point above it. Okay, hopefully my pencil tip, you can see that show up. So this is 0, -1. This is 2, 2. Okay, and I want to go from 0, -1 to 2, 2. That's my goal. And I should be able to find the slope of that line using rise over run. Okay? So let's start down here at the bottom at 0, 1. Now I'm going to go straight up. That's rise when you go straight up. So I have to go up because my point that I'm trying to get to is above me. So I want to go up. So I'm going to go up 1, 2, 3. Okay? So when I do this, let me rewrite it here, I just physically went up 3. That plus sign means I went up, and 3 means how many blocks did I go up. So I'll do it again. Here is my pencil tip at 0, -1. I went up 3. 1, 2, 3. Okay? Now, I'm on the same level as the point I'm trying to get to. That's how you know when to stop, is when you get to the same level. Well, I'm now on the same exact level as 2, 2. So now it's time to run over to it. Now, if you go right, that means you went positively. If you move left, you're moving negatively. Okay? So I'm going to start here where I finished up with my rise, and I'm going to run 1, 2. So I went to the right 2. So my slope is 3 over 2. Now when you do slope, you generally don't need to turn it into decimal form. So don't think you've got to change it to 1.5. You don't have to do that, okay? Maybe in a word problem, but when we're just doing general calculating of slope of a line, it's not attached to any kind of word problem, don't worry about changing it. Just maybe reduce your fraction if necessary, leave it in improper fraction form is totally fine. Don't change it from there, okay? So that's how you do that, going from 0, -1 to 2, 2, okay? Now, let's see, would it be the same exact thing if I started at 2, 2 and then work my way down to 0, -1? Would it be the same thing? Well, let's see. All right, start at 2, 2. Now remember, rise means I have to go up or down. Well, my point that I'm trying to get to is below me. So I need to go down. All right, so let's start here. Let's go down. 1, 2, 3. You stop as soon as you're on the same level as the point you're trying to get to. Okay, so this time, because I went down, my rise is -3. Negative means down, okay? Down 3 units. All right, now let's start at that place where we finished up with the rise, and let's run over to the point. So I'm going to go left 1, 2 units. So I went left, that's -2 units, okay? So, of course, let me ask you just a real basic algebra question. What's a negative divided by a negative? And if you are thinking, oh, positive, you are absolutely correct. So, for all intents and purposes, what you need to know is it doesn't matter if you start at the lower point and go up to the higher point, or if you start at the higher point and go to the lower point. Either way, you should get the same exact slope, regardless of how you do it. So that's why I showed it to you both ways, like that. Now, could you have gone from the lowest point here all the way up to the highest point, which looks like it's 1, 2, 3, 4, 1, 2, 3, 4, which looks like it's 0.45. Could you have gone from the lowest point to the highest point? Would it still be the same exact slope? Well, let's see. Let's let the numbers show us how it's supposed to turn out, okay? So I'm going to set up rise over run again, and it doesn't matter if I start from the lowest point and go to the highest point, or start at the highest point and go to the lowest point. It doesn't matter. They should have the same slope. So let's check it out. I'm going to start at the lower one, okay? So let's rise. We're going to go up 1, 2, 3, 4, 5, 6. Now you know when to stop is when you're on the same level as the point you're trying to get to. That's how you know when you can stop rising, when you're on the same level, okay? Now we're at +6, so if I go up, that's positive, and I'm getting ready to go right, that's also positive. So let's count over. 1, 2, 3, 4. So I went right 4. Now I have a fraction, 6 over 4, both are positive, but let's reduce it. What number will reduce both 6 and 4? If you said 2, you're exactly right. And oh, look at that. What did we just discover? It's the same thing. So let's make a relationship here. I want you to relate some information. It doesn't matter if you do a little segment from here to here, or the bigger segment from 0, -1 up to 4, 5. If it's a straight line, it should have the same exact slope anywhere on that line. You should be able to calculate the same slope. And we did. We did 3/2. That is the slope of our line in this particular example. Okay? So hopefully I've made a little sense there. You can, as an alternative, if you don't like rise over run, you can do the change in y over the change in x. So you could do here's the change in y, 2 minus a -1, well that's 3, and then 2 minus 0, which is 2. You'd still get 3/2. So you could do it that way, kind of like we did in the first two examples. Okay, let's move over here. I'm going to label this one B. And it's leaning differently, so it's leaning back to the left. And there's several points that I've shown you, and we want to find the slope of this line. Now remember, that long line, you can do any 2 points. You can do these first 2 points, you can do these 2 points, you can do the longer segment, the longest segment. It doesn't matter. You can pick any 2 points and do rise over run on it. Okay, and it should be the same for all of them, and we'll just check that out. So I'm going to start down here. It doesn't matter what the name of that point is. If you want to name it, go right ahead. It's 2, -2, if that helps you. And here's 2, -2, and this is 0, -1. And what we can do is I again want to show you how this works, okay, using rise over run. So I'm going to write rise over run right here. I'm going to start with the lower point, 2, -2, and I'm going to rise and then run back to 0, -1. That's how I'm going to do it. So let's start at 2, -2. I went up 1. When you go up, that's positive. So I went up 1 unit. So here I am. Now I'm going to run -2. That's 1, 2. I went left 2. So that's negative. So the slope of this line is -1/2. And you can put that negative sign with the 1, with the 2, it doesn't really matter. Just make sure that the fraction is negative. So -1/2, you can write it like this, you can write it like this, or just out here in no man's land, just like that. It all means the same thing. That fraction is -1/2. It doesn't matter. Okay, now just for your sake, I'd like to show you how to go from 0, -1 down to 2, 2. So I'm going to start at 0, -1. I'm going to go down 1. Okay, so that's -1. And then from here, I'm going to go right 2. That's +2. Do you see how the fraction is still -1/2? So it doesn't matter if I go at the higher point and come down to the lower point, or I go from the lower point up to the higher point. It doesn't matter. I'm going to get the same slope. And again, it doesn't matter if I start at the lowest point and go all the way up here to the highest point, which is -1, 2, 3. That's -4, +1. It doesn't matter if I do the biggest one to the smallest point on my line. It really doesn't matter. It all should actually calculate out to be -1/2 is the slope. Okay, we're going to stop right there. The next page is just a very grainy picture from your book. They're trying to show you the same thing, that you can go low to high or high down to low using rise over run. So if we start low, go up 2 over 1, go down 2, back 1. Now some of you are like, how you went way more than 1. This particular example, let me kind of show you with my stylus. Look at the increments. Do you see that +1 is right there? You have to pay attention to the increments. It takes you, this middle number right here is actually 1/2. So if you start at 0, 0 right there, and you go up 1, you didn't go up 1, you went 1 box, but the increment is 1/2, so you went up 1/2. So if you want to go up 1, you have to go up 2 boxes to the +1. That's how it works, okay? So that in this example, if you go up 2 boxes, that's +1. You go up 2 more boxes, that's +2. That's based on the example. Pay attention to the increments on your graph. They do not always go by ones. You have to pay attention, okay? So if you're not, some students are going to make this mistake. They're going to count it this way, and they're going to go, oh, I went up 1, 2, 3, 4. You did not go up 4 whole units. You went up 4 half units, which is equivalent to the number 2. So this is how you count it. You're going to go up 1 more. That's 2. That's a positive 2, okay? And you have to pay attention to how the units on your x-axis are going. They did it the same way on the x-axis. So you have to go over 2 units just to go 1 whole. So we went right 1. So please pay attention to the increments. If none of that made sense, then please stop the video, rewind to this beginning of this, and let's talk about it, write some questions down. But the increments do matter. Just because you go up 1 box on your graph doesn't mean you actually went up 1, unless the increment is 1. If the increment's something else, you have to count that increment. So if your graph is going up by hundreds, and then you have to count by hundreds if that's the increment. Okay, now just to do a quick review, if you'll flip back in your packet to the try it on your own, here's one for you. Try rise over run on this page and see what you can do with it. Good luck.